Yeah. Copy, copy. Grab one of them. Cool. So a bit of an unrecoverable issue with the previous streaming link, but we will begin. Of course, my name is Trent, your favorite DJI solutions engineer. Today we're going to be going through the DJI developer platform, building an AI model for the Matrice series, and just reviewing some of the ins and outs and details about how to make a model, make an AI object detection model. So there's a lot of information out there, and it can get very technical. So I've done a Google Collab file where you can jump in. We're going to grab a data set from RoboFlow, and that could be anything, and it's just to give you ideas on what would be possible. And if there's a really good idea, that should be like submitted to the Onboard Enterprise Challenge, where like DJI is going to give us a Pocket 3, which is really good, or a manifold if it's the best one. So to make the models for the drone, we're doing onboard image processing, which is this object detection. It's pretty basic and it's running on the drone. But the more advanced ones will get higher detections, let us control the drone, and that will be used on like the Manifold 3. But to begin, we go to developer.dji.com and we request a developer account. We fill in some details, so we just sign in as usual. Once we get to this page, we have algorithms on aircraft or algorithms in the cloud. In the cloud, that's going to be a process where you're running your own object detection algorithm on video. You have video coming in, streaming to you. You're detecting it and sending the detections back on a frame that DJI will render afterwards on top of your video. But the more common one, the easier one to use that's going to work in the field without internet, is the algorithms on the aircraft. So it says, we obtain the model source code, train the model locally, upload to developer platform, and then distribute. So straightforward, we want to develop the algorithms. Sign in. So I'll assume, let's say we sign in. I'll jump over here and do that. Once we sign in, we can click get the model. We're going to get a few things. We're going to get this folder here is going to be the key piece. These are the instructions they give us. Very technical. We're getting a YOLO model. That's what we're making. You only look once is what it means, which is just a fast image detection. And we can jump over to the GitHub and see how that works. So it's a bit of a framework, an open source framework with like image segmentation, object detection, and a lot of different methods all like wrapped up into one system here. So and it gives us these like key pieces. This is what we need to follow. We get the project from GitHub, we get a specific version of it, then we apply the git patch file, which we downloaded from DJI Dev with this beside it. Then we train it according to the configuration file. We control the number of categories. Let's say it only wants 10. That's like one of the maximums. The aircraft doesn't want to handle more than 10. It's just going to reject it and it won't upload to the platform, or it won't quantize at the end. So then just further, we're just getting a PTH file, which is like a checkpoint file for the model that we've made. So we're getting the checkpoint file and a zip file full of photos to be tested on, and those are the two things we're going to submit to the platform. Once it's there, we can distribute it to any aircraft based on the serial number. This will let us just open the device, press refresh if it's a dock, or we can use an SD card to input the new model, and then it becomes available in like a drop-down selector on the drone itself. So to make a model, we need lots of images. A valuable model or a useful model or a unique one is going to be done on images that are unique to everyone's business or everyone's like situation. So the internet is full of models of the most common objects. So we've got RoboFlow Universe, where we can jump in and just find basically anything, data sets of everything. So people, forklifts, I'm just going through it at random. Hard hats, an easy one. That was like one of the first models I was testing on. Back when the Matrice 4 came out, you can just grab one of these and test it and see if there's a use case for it. But is the imagery good enough? So if we jump into this, we're going to get people with hard hats, makes sense. We can click into the individual images. These look good, but this will work at a ground level perspective. It's probably not going to work where we want to recognize things that are similar to what the drone is seeing. So the drone is flying at, let's say, 50, 100 meters. The images that we want to train the model on are going to be images that are taken at a similar altitude, a similar perspective. We want to give it images of diverse locations, so it's not overfitting to the model, where it'll only recognize the images from one location. So we give it a diverse range of images to be more capable, to be more useful. So for example, today, we want to make a model to do power poles, let's say. Just a very basic box detection of the pole itself. So I've come over, found this data set. This one has a lot of images of power poles, and they've gone through, they've annotated. We've got tools here to annotate the images, which is what the model is learning to recognize. So we can add more annotations. So if we jump in, we can close that up. We call this a conductor. That's probably the wrong word. Probably the wrong word. But it's not part of the, let's say it's not part of the list. But people have gone through and annotated all of these. So when we start from scratch, we grab, so I'm going to jump into classes. I'm going to go back to power poles. So I'm just looking, starting from scratch, I'm looking for the ones that are going to be most similar to what the drone is going to see. So that one is good. These are decent. Jump over to the next page. Okay, they're getting a bit more abstract with what they call a power pole. I'll grab like this one. So I want to use the data set. In RoboFlow, all of the data on all these sets are public, so we can merge multiple sets together. So I can just jump in and go fork it. I want to use the whole data set. While that's duplicating, I can also jump in. And if another set has better images, or we want to make something more diverse, I can select a few of them. I can select clone them into the previous one. So jump 50 more images. Now it's going to be a more robust model that we get at the end, where we have more images, more diversity. Then we can jump in to find the data set itself. So this is one data set, and I've merged it with another one, and they've called the same object multiple things. So they've been annotated in different ways, or different people have called this a pole or a light pole or a post. And there's going to be a list of multiple annotations. So we can modify that and just sort it down to what's useful. We can also remove the annotations from where there's conductors or just things that we're not aiming for, and we can remove those there. So that will remove the specific annotation on the image. Then I can come back to the versions, create a new version of the data set. Here we've got steps to do pre-processing. So it'll let us adjust how the image is built. So here we've got a folder of 1,000 images. We have the splits. In training, we have images that are trained on that are kept in one box, images that are 100% valid, which the model will know and it's not training on it, and then it has test data at the end. So it goes through a process of training and validation, where it adjusts its expectations of what it needs to look for or what it's learning from. So at a certain point, if it's not learning and it sees from the valid data that it's actually getting worse, we can see that, we could end the model. We're not going to waste time continuing down that pathway. Then we can check out the processing steps. In this case, with the model that we're going to make, we don't need any of the pre-processing steps, and there's a lot of things to get into where we can have one data set of like 500 images, and with rotating them, skewing them, making some black and white, we're turning 500 images into 5,000 images. So in this case, we're going to remove these. We're going to skip doing them. Similar to augmentation, hue, saturation, brightness as well. But all of this is just manually doing it. So it's doing the editing and the adjustments and duplicating them when we take them out of RoboFlow. But all of this can also just be done in the augmentations within creating the model. So we can review that as well later. So at a certain point, we just want to create the data set. I'll skip these. New data set, new version, name it something better than the automatic. So it's basically just zipping all these images from the original image that somebody's uploaded here is key to that person's project and profile, and then you've merged it with images from somewhere else. Maybe you've adjusted the annotations, you've removed annotations or added your own to the same image, but it's just bundling all of that together into a new version, a new package to process out. But we can jump back to the one I did before and just go download the data set. There's different image and annotation formats. So of course, everyone will have their own certain type for certain models. So we want the detection for the YOLO. What that looks like is, I'll jump over to here. So if we did download that direct to the computer, it's going to give us a folder like this. We've got a text file of just metadata, the folder of valid, the folder of test, the folder of train. And this is basically just changing the format, the folder structure we expect when we download it. And it's also going to change what it looks like with the annotations here. So inside valid, we have a coco.json, and this is what it is. It is the annotation of this image has a bounding box at this height in pixels at this. And we have a name for it, that these can all be, let's say, I'm just skimming across now. License widths, just the metadata, basically the metadata of where the annotation is. So this is all pretty unreadable as well. But we could zip it. We'll download this. I've already have it because we do want to grab some of those like raw images. We'll grab the download code and continue. So I can copy this. This will let us pull the images into the Google Collab detection tutorial I built up. In the previous link, I'm going to add it here as well after this one is complete. But just copy that. Basically going to give us just an overview of how this works. So Google Collab is great. We can connect to a hosted runtime, so we don't need a GPU computer with us. We can actually get very powerful ones like a H100, the A100, but we'll use the T4 because I believe it is still free and we do get some credit times. We're basically paying for credit times for this. So I can view resources and see how much it costs per hour, like tokens for an AI. So we'll begin, we're just detecting one class, which is the pole. We could have up to 10 of these. This is the color palette for the final detection, so that looks like it's red. And then we have a project name. The number of epochs and the batch size. So the epochs are how many validation training runs it's going to go until it completes. And the batch size is how many jobs it's going to run in parallel. So in batch size of 16, it's going to send out 16 training tasks at the same time, send 16 back. And this will be contained, or this will be, this number should fit within how much like GPU RAM we have. So something like the A100, we can bump this up to 32, something in multiples of 2 like that, so 816. So we connected, press run, we set the settings. Basically, this is just checking out which GPU we have, confirms it. Then we install Miniconda. So this isn't part of like the direct steps from the DJI booklet of their tutorial, but using Miniconda just lets us put all the packages together in a way that's not going to conflict with each other. So it's something I ran into early doing this, is we've got a lot of conflicts and it has very specific requirements on what version of PyTorch, what version of YOLO are going to work together. Do they both work together on the same GPU? And is Google Collab also adjusting what they're using? So there's a lot of conflicts and that changes, but Miniconda just lets us wrap it together in a virtual machine within a virtual machine, let's say, and just run it within a known environment. Then inside Miniconda, we create the YOLO environment. then it'll say complete in a second. We install OpenGL, just dependencies for what we're going to get down to. PyTorch is the general computer vision framework, as well as Onyx, which is going to be a more general, like open, it's like an open file format for these AI models here. So we get Torch, Torch Vision, MMCV, all very specific ones that just need to work together. Here, we want the DJI patch file. So when we're using MMYOLO, DJI needs us to put in the patch file, and it just locks down or adjusts certain settings. So it's like that's their version of MMYOLO, a very specific one. So I can grab from before. So from what we downloaded, we grab the patch file, drop it into our file bucket on the left there, and we have its path, it's found, and it gets recognized. The next piece, we get MMYOLO, we get that version 0.6, which it asks us for, and we apply the patch. Next step, we are going to jump in, build it, and install MMYOLO. This piece is it's adjusting the training script from MMYOLO, so we can output an Onyx version of the PTH file. Then we are preparing the data set. There's some more information on just what to put in here, but we've got from our download page, we jump in and we can paste that here. That's going to let us pull in all the images. It's going to extract them because that was zipped up. Next, we are cleaning up the annotations. The annotations were all labeled in Cocoa format to be starting at 1. So you have class 1, 2, 3, 4. But the model was expecting them to be done in class 0. So we just strip that data back, pull everything back one step so it doesn't fail or it doesn't train on the wrong thing. So it's not expecting it, and it's not, it'll train, but it's not training on what it expects to be finding. So all the annotations and connections would be incorrect. The next piece is writing the training file, which was coming from the DJI document. So we just click run, and it's going to generate a new Python file with these adjustments. So we're grabbing the base Python file and making a new version. This is, let's say, the training pipeline. So the training pipeline loads images, bounding boxes, has some padding. This is like some of the augmentations. We're doing the mosaic augmentation. We're not doing a shear degree, but we could adjust that. We're not doing letter resizing, but we got like image scale has an effector. So in the training, in the validation pipeline, we can adjust these images ever so slightly just to give it something that's not going to overfit. Then it outputs it into our sample project. We validate the file looks good, and then we can begin training. So once we begin training, there's some other cells that we're running before this. Once we begin training, we're going to see like epoch 1 begins, then the training steps, validation steps, then epoch 2 begins. So we'll see how far down and what we're waiting for. I'll scroll back up because this is going to take, this will take about 4 hours or so. We're going to be done much sooner than that because I'm just going to jump over to what we had done earlier. Okay. So let's say we run the training step. At a certain point, it's going to start generating the PTH files at like checkpoint 10, checkpoint 20, checkpoint 30. And if you stopped it at 50, it's just going to stop at 50. But if we bring it up to like 200 is a good number where it can continue training, but it may not be learning anything new. There is a bit of a fall off in how good it could possibly get. But if you do some research into this, it could be 400, 500. We just don't want to be training it where we're not getting any results. So we do have those steps in as well. So we do have like assign one of these to be the best and just double check it. So it'll tell us if we stop, if we continually get the same results, it's going to stop it as well. Here we're just doing an evaluation. Then we do visualize predictions. So we're doing an inference on a random set of those images. That is going to look like one of these pieces. I can jump open. So it's pulled the image, it's done the inference, and it's 40% confident on this poll. So this one was the 4-hour run on the 1,000 images. 50% confident, 23, 30, but it's doubled up there. Not very good. Once we check the images, we can see, is it good, is it bad? Obviously, this one was not good. Your one can be better. So we download the PTH. So we grab the most recent train checkpoint, and also we get to package for the DJI. So it pulls about 500 to 1,000 images if they're available, and zips them up as well. And that will let us get the PTH file. I'll pull up one of them. Okay, so before we got the best, Epoch 50 was the best one. So we download the PTH file. Then we jump over to the images themselves. So I would jump over into the test portion, just grab a random set of these that we downloaded earlier, compress them to a zip. So I'll jump back into the DJI platform. Going to algorithm dev, develop the algorithm. This is where the obtained model was. We got model management. Okay. Okay, platform is very slow here. I'm gonna ignore this since it's not working, but there we go. So we can do upload the model. We're gonna upload the PTH file. We'll upload the zip of it and we'll proceed. We're gonna call them the list of annotations starting from 0. 0 will be poll, and then we can confirm, submit it. Once it submits, we ask it to do a validation. Once it validates, we can distribute it. Then we do a new distribution. We do new test. We import a text file, so we can get a template text file. The text file is just an empty file with the drone serial number. We grab the model that we made, the expiration date, so it will remove itself, or let's say not be available in the selection system at a certain date. And we've also got overrides for what it should be for confidence and the overlap, so we can confirm and distribute that. That will let us get these models working on the drone for whichever instance you want to do. For example, one of the more recent ones is the cow detection model for the ag drone ag dock system. So here, of course, as we know, there's only people, cars, and boats that work on the drone. But here we're doing cow detection. We can do cow counting on paddocks, which is a very live system, and it's coming from that, like that general data online, but it's getting augmented by the data that's collected in the field, which is making it a lot more valuable to have this found or to have this more accurate data. So you're not going to get this image. This image won't be found online. It's coming from that sort of data, and this is a more general way of doing it than compared to, there's a lot of multispectral stuff that's going to need its own detections, but this is something that could be done, as well as the hard hats will be done for safety and like the endless amount of ideas from that. So please, if you have any questions, I wasn't reading anything in the comments. Sorry, Dimitri. I'll send you an email afterwards once I read that. But yeah, reach out if you have any questions. I think the point of this is the drones are as good as they could ever possibly get. Well, not really. They're as good as they've ever been. We need to do more with the data that we're getting out of them. So doing this, having the platform available on the DJI drones is well needed, and it's great to see. And I'd love to see more people making models. And I can share the collab. It should be open if that's possible, but if we don't need to be going to those steps, you can reach out and we can work to develop something from the data you have. So thank you for the stream, joining us if you were here. I'm gonna repost this afterwards. Thank you.